Good morning students. Today onwards we will going to discuss about the characteristic impedance of the pi section. In case of the characteristic impedance of the pi section, we will going to discuss it to find out the output impedance of the characteristics impedance of the pi section, where Z of in is able to apply across the input side here, and to find out the output impedance Z0. For this case, the Z1, 2Z2, 2Z2 here is to be input port 1 and 1 dash. For this input port we have able to apply the input impedance, and for output impedance there is a Z0 we have find out at the port 2, 2 dash. For Z1, 2Z2, 2Z2 is the parallel combination, and this basically the pi network. This is the pi network, and we have able to apply for this pi network. This is the input impedance, and here is the Z0 is the output impedance. So our aim is to be find out the Z0. Basically, in case of the T section, Z0 which is equal to root of Z1 Z2 plus 4Z2 upon Z1 square. That will be given the equation for the in previously we have seen ZOT which is equal to Z1 Z2 into 1 plus Z1 upon 4 Z2. For this, the characteristic impedance of the pi section, and for this characteristic impedance of the pi section again we have find out the output impedance. So that the Zin, for this case what happens, the due to the source applied at the input port I1 and I2, the current will be divided to the here. Means basically the current is divided at the two junctions here, and the current is flowing through 2Z2 to Z2 in this way also. Means while here the respective 2Z2 in parallel with the Z0 in a parallel series combination of this in parallel with the 2Z2. In this way we have to be find out the output impedance Z0. So Z1 in which is equal to Z1 plus 2Z2 Z0 upon 2Z2 plus Z0 in parallel with the 2Z2. So that after the simplification here, the Z1 plus 2Z2 Z0 upon 2Z2 plus Z0 plus 2Z2 means basically for here the 2Z2 is parallel combination of this, means Z1 plus this parallel combination means 2Z2 and Z0 is the parallel in series with the Z1, and this whole parameter is in parallel with the 2Z2. In this way we have to be find out the value of the Z1 in, which is equal to Z1 plus 2Z2 Z0 upon 2Z2 plus Z0 in combination of the 2Z2 upon Z1 plus 2Z2 Z0 upon 2Z2 plus Z0 plus 2Z2. When Z in which is equal to Z0 for a symmetrical pi network, so its characteristic impedance we have to be find out after the simplification of this. Then ZO pi which is equal to root of Z1 Z2 upon 1 plus Z1 upon 4 Z2. Means there is a this parameter is come in a multiplication factor in denominator Z1 Z2 inside the bracket of 1 plus Z1 upon 4 Z2. But in case of the pi section, only the difference is this Z1 Z2 this parameter come in the numerator, and 1 plus Z1 upon 4 Z2 this parameter is come in the denominator side. So that here the Z1C there is a open circuited for the T network, so that ZOC open circuited. Therefore Z1 Z2 if it is the open circuited means the 2 and 2 dash, there are the two condition will be arises. First condition is that the 2 dash or 2 it is the open circuited, means you cannot able to apply the Z0. This is the first condition, means The first condition is the open circuited, means here is the open circuit, and the second condition about that, it is the short circuited. Is one case for the open circuited and another case for the short circuited. So open circuited, what happens, the Z1 upon 2 in series with the Z2, because there is a no any current is flowing through the this terminal, means no any current is flowing through the Z1 upon 2. That's why Z1 upon 2 in series with the Z2. This is the open circuited. So that Z1 OC, which is equal to ZOC, which is equal to Z1 by 2 plus Z2. If it is the short circuited, means the 2 dash is the short circuited. If the short circuited, then Z1 by 2 plus the parallel combination of these two, means the Z1 SC, which is equal to ZSC, which is equal to Z1 upon 2 plus Z1 Z2 upon 2 upon Z1 by 2 plus Z2. So that if the Z1 OC, which is equal to Z1 SC, means open circuited, and there is a short circuited, if we have to be multiply the two terms, means there is a ZOC into ZSC, then Z1 square upon 4 plus Z1 Z2, and this equation is basically the output impedance about that ZO square. So that ZOC ZSC, which is equal to ZO square, therefore, or ZOC into ZSC, which is equal to ZO pi square. So that what we do here, for this open circuited and short circuited for the T network, and open circuited and short circuited for the pi network, then we realize that your output impedance, which is equal to square root of the impedance of the open circuited into the impedance of the short circuited. So that we have to be find the relationship ZO, which is equal to ZOC into ZSC. We prove that. Then the propagation constant gamma. In case of the propagation constant gamma, under the assumption of the equal input and output impedances, which may be the Z0 for the symmetrical network or the current ratio. So how to find out the propagation constant? Basically we know that on the foundation, the gamma, which is equal to alpha plus j beta, alpha plus j beta. What is this? Alpha is the attenuation constant and beta stands for the phase constant. So that your propagation constant is the combination of your phase as well as the attenuation, combination of the both. So the magnitude ratio does not express the complete network performance, the phase angle between the current being needed as well. So the use of the exponential can be extended to include the phase current ratio if it is defined under the condition of the Z0. So we find out to take the ratio I1 upon I2, which is equal to e raised to gamma, is to take the ratio of the current I1 upon I2, which is equal to exponential function of the gamma power. So that we know the gamma is the complex number defined. So that the gamma, which is equal to alpha plus j beta, gamma which is equal to alpha plus j beta. Hence the I1 upon I2, which is equal to e raised to gamma, and this gamma, which is equal to alpha plus j beta. If we have to take the ratio I1 upon I2, which is equal to A at an angle of the phase constant beta. So A, which is equal to I1 upon I2, and I1 upon I2, which is equal to e raised to gamma, and beta, which is equal to e raised to j beta, e raised to j beta. Okay. Then the output impedance termination is a ratio V1 upon V2, which is equal to e raised to gamma also, in case of the to take the current ratio. So the term gamma has been given the name of the propagation constant. So that alpha, which is equal to the attenuation constant, it determines the magnitude ratio between the input and output quantity. So it is the attenuation produced in passing the network and the units of the attenuation is Neper. Okay, means the unit of this alpha which is equal to Neper. So B is the phase constant, means propagation constant gamma which is equal to alpha plus j beta. Alpha is the attenuation constant and beta is the phase constant. So that beta which is equal to phase constant, and it determines the phase angle between the input and output quantities. So the phase shift introduced by the network, the delay undergo by the signal as it is passed through the network. If the phase shift occurs, it indicates the propagation of the signal through the network, and the unit of the phase shift is the radians. So what we do after that, if the number of the sections of all common output impedances Z0 is the ratio of the current, there is I1 upon I2, I2 upon I3, I3 upon I4, I5 upon I6 in this way. So that I1 upon I2 into I2 upon I3 into I3 upon I4 up to the I1 upon I1, from which we have to be take the ratio. There is a e raised to gamma 1, then for this e raised to gamma 2, for third e raised to gamma 3, in this way up to the e raised to gamma n, and take the natural logarithm of that. Once we have to be take the natural logarithm of this, then this equation is modified here. There is a gamma 1, gamma 2, gamma 3 up to the gamma of n. Thus overall propagation constant is equal to the sum of the individual propagation constants. That's why once we have to be take the natural logarithm of e raised to gamma n, it will be represented by the gamma n. So that the overall propagation constant is equal to the sum of the individual propagation constant. So here the physical properties of the symmetrical network. Then what we do, instead of the input impedance, we have to be apply the voltage source or impedances, EMF, and due to that the current is flowing through the first loop and second loop also. So use the definition of the gamma. We have to be introduction about the e raised to gamma as the ratio of the current I1 upon I2. We have to be take the ratio of I1 upon I2, and to find out the terminating load impedances, generally which is called as the output impedances, which leads to useful result. So for the T network, the figure considered equivalent to any connected symmetrical network, we have to be take the ratio I1 upon I2. Then I1 is the actually the current is flowing through Z1 by 2 plus Z2 plus Z0 here. Z1 by 2 plus Z2 plus Z0 is the current is flowing through the network, and I2 is the basically the current is flowing through Z2. So that here to take the ratio, then where the characteristic impedance is given by Z0 square, which is equal to Z1 square upon 4 plus Z1 upon Z2 for the T network, only. So the propagation constant gamma can be related to the network parameter as follow: e raised to gamma, which is equal to 1 plus, basically where is e raised to gamma? Here is to given the e raised to gamma. Okay, based upon I have written the equation 1 plus 2 Z1 upon 2 Z2 plus root of Z1 upon 2 Z2 square plus Z1 upon Z2. Once we have to be take the natural logarithm of this all parameters, means once we have to be take the natural logarithm of this parameter, then e raised to gamma is represented by gamma. So that natural logarithm of 1 plus Z1 upon 2 Z2 plus root of Z1 upon 2 Z2 square plus Z1 upon Z2. So that Zin which is equal to Z11 minus Z12 square upon Z22. So that the Zin which is equal to Z0, Z cos hyperbolic function of gamma plus Z0 sine hyperbolic function of gamma. Then just opposite parameter view right now here, Z0 cos hyperbolic function of gamma plus Zr sine hyperbolic function of gamma. So here is the hyperbolic function should be given, and for that hyperbolic function gamma, which is equal to natural logarithm of 1 plus z1 upon 2 z2 plus root of z1 upon 2 z2 square plus z1 upon z2. Then what we do here, after to taking here z in, which is equal to z11 minus z12 square upon z22, but we know that this value zr, which is equal to z0 zr cos hyperbolic function of gamma plus z0 sin hyperbolic function of gamma upon z0 cos hyperbolic function of gamma plus zr sin hyperbolic function of the gamma. So for the short circuit, your output impedance zr, which is equal to 0, because we have to be connected to 2 dash or 2 network should be short circuited. So in case of the short circuited, ZSC, which is equal to Z0 tan hyperbolic function of gamma, or for the open circuited, there is ZR, which is equal to infinity, because this is the open circuited, so that your Z, which is equal to Z0 upon tan hyperbolic function of the gamma. So from these two equations we can see that or show that the tan hyperbolic function of gamma, which is equal to ZSC upon ZOC. But we know the ZO, which is equal to square root of ZOC into ZSC. So what we do here, the propagation constant gamma and the characteristic impedance Z0 can be evaluated using the measurable parameters in concern with the ZOC and ZSC. Okay, then filter fundamentals, and in case of the filter fundamentals, we have seen for that relationship of the propagation constant. The propagation constant for the filter fundamentals in case of the pass band and stop band, your propagation constant gamma, which is equal to alpha plus z beta. When alpha, which is equal to 0, then I1, which is equal to I2, and there is no attenuation, only the phase shift occurs in the pass band. Okay, means alpha, which is equal to 0, means gamma, which is equal to z beta. Okay, simple. So that only there is no any attenuation parameter, only the phase shift occurs in the pass band. If the alpha is the positive, again there are the condition. My dear student, you just remember these things to keep in mind. When alpha, which is alpha is the positive, then your I1 should be less than I2. If your I2 is greater than I1, then attenuation occurs in the stop band. Attenuation occurs in the stop band. So for gamma is conveniently studied by use of the expression the sine hyperbolic function of the gamma by 2, which is equal to root of z1 upon 4 z2. Then it can be proved that from this the pass band condition is a follow if this parameter z1 upon 4 z2 should be greater than -1, but it is less than the 0. So where the two reactants are opposite type, the phase shift in the pass band, so that this phase shift in the pass band should be calculated beta, which is equal to 2 sine inverse of root of z1 upon 4 z2. Since the z1 and z2 may have a number of the combinations as the L and C element, or as the parallel and series combinations, a variety of the type of the performance are the possible. Up to this video you have to be understand about that a very important parameter about the fundamental or constant K type of the filter, which is called as the propagation constant, as well as the characteristic impedance of the pi section and T section. Just I have to be summarized once again. The characteristic impedance of the T section will be categorized at its equation about the ZOT, which is equal to Z1 Z2 into 1 plus Z1 into 4 Z2. In case of the pi section, the Zin, which is equal to here ZO square, and the relationship we have seen for the two conditions, open circuit and short circuited, the ZO, which is equal to root of ZOC and ZSC. Then propagation constant, The propagation constant is given. The magnitude ratio does not express the complete network performance and the phase angle between the current being needed as well. So alpha, which is equal to z beta. So here the attenuation factor generally measured in the Nipper, and P is the phase constant. Then we have take the ratio of the current or ratio of the voltages to find out it. Then physical properties of the symmetrical network, then to find out its alpha, beta and gamma value. Then filter fundamentals, we have seen the pass band and stop band, the propagation constant gamma, which is equal to alpha plus z beta, and its relationship we have seen here. From my next video we will going to discuss about the constant K type of the filter, its different types and derivation and fundamentals. Thank you. If any query, any doubts, please write on my comment page. Please subscribe my channel, share and like my video, and please press the bell icon. Thank you. Have a nice day.